In this lesson, we are going to discuss about mathematical operations with array. So let's start with addition and subtraction. I hope you are familiar with addition and subtraction of matrix. Let's say we have two matrix A and B. If we do A plus B, this is what we get. Matrix A plus matrix B. The answer will be the first element of A plus the first element of B, second element of A of row 1 plus second element of B in row 1, and so on and so forth. So let's look at how we do this in MATLAB. Let's say we have a vector A that is equal to 8, 5, and 4. And we also have a vector B that is equal to 10, 2, and 7. So since I put semicolon at the end, so these two vectors will not be displayed by MATLAB, but they appear in the workspace over here. So let's say we want vector C to be equal to vector A plus vector B. Then we get the answer of this 18, 7, and 11. So 8, first element of A will be added to first element of B, second element of A added with second element of B, and the third element of A will be plus with third element of B. So you get this answer here. Let's say we have a matrix now, matrix A that is equal to 5, minus 3, 8, next row 9, 2, and 10. So this is a 2 by 3 matrix. Then we have another matrix B that is equal to 10, 7, 4, next row minus 11, 15, and 1. Remember that for matrix addition and subtraction, the dimension must agree. So now here we have a 2 by 3 and 2 by 3. So then we can go ahead and do A minus B, for example. So we get the first element, first row A, first row, first column of A will be minus first row, first column of B. So 5 minus 10, we get minus 5. Second row, second column, first row, second column of A, minus 3, minus first row, second column of B. So you get minus 10, and so on. Let's say we have a matrix C, for example, that is another dimension. Let's say I have 1, 2, 3, 4, 5, 6, another row 7, 8, 9. Okay, so this is our matrix C. This is a 3 by 3. So if I do, for example, A plus C, MATLAB will give an error because A is a 2 by 3 matrix, C is a 3 by 3 matrix. So the dimension of these two matrices does not agree, so it cannot be added or subtracted. So the same error will appear if I do subtraction of this matrix. Okay. And of course, we can also do addition. Let's say D is now equal to A plus B. Now we can do this because A and B has the same dimension, 2 by 3 and also 2 by 3. So we get 5 plus 10 minus 3 plus 4, minus 3 plus 7, you get 4, 8 plus 4, you get 12, and so on. Now let's say we go to another example. We have a vector A, for example, to have 1, 5, 8, minus 10, and 2. So this is our vector A. And we do vector A plus 4. So when we press enter, all the elements in vector A will be added with 4. So 1 plus 4, 5, 5 plus 4, 9, 8 plus 4, 12, and so on. We can do the same for matrix. For example, we have matrix A that is equal to 6, 21, minus 15, 0, minus 4, and 8. So this is our matrix A, and if we do A minus 5, so what we get is all of the elements in matrix A will be subtracted with 5. So 6 minus 5, you got 1, 21 minus 5 is 16, and so on and so forth. Now let's take a look at matrix multiplication. So multiplication of matrix is executed by the rules of linear algebra in MATLAB. So let's say we have a 4 by 3 matrix of A and a 3 by 2 matrix of B. So according to the rules of linear algebra, a 4 by 3 matrix multiply with a 3 by 2 matrix will give you a 4 by 2 matrix. So the inner dimension must agree. For example, here is 4 by 3 and 3 by 2. So this 2 agrees. So you will get 4 by 2. So how matrix multiplication is performed is like this. So A11 times B11 plus A12 times B21 plus A13 times B31. That will be one element. And so on goes for the other elements as well. So let's take a look at array multiplication in MATLAB. So say we have a matrix A that is equal to 1. So this is our matrix A. We have here a 4 by 3 matrix of A. Then we have a matrix B. So this is our matrix B of 3 by 2. So we have 4 by 3 and 3 by 2. So now we can do a multiplication of this. C is equal to A times B, for example. So what we get is a 4 by 2 matrix. This will go according to the rules of linear algebra. What if we do D is equal to B times A? Now B is a 3 by 2. We want to multiply it with 4 by 3. So definitely we will get an error because the inner dimension does not agree. Inner dimension of these two matrix does not agree. This is a 3 by 2 and 4 by 3. So the inner dimension is not agree. This one is 2, this one is 4. So we can only multiply A with B because A is 4 by 3 and this is 3 by 2. So 3 and 3 can be multiplied together. So another example is, let's say we have matrix F of 1, 3, 5, and 7. This is matrix F. And then we have matrix G that is equal to 4, 2, 1, and 6. Okay. Now if we do F times G, we will get this answer. This is a 2 by 2 multiply with 2 by 2. And because this is a square matrix, we can also do G times F, which will not result in an error because the inner dimension of this matrix agree. Okay. Let's say we have now a vector, a row vector of 3 elements. So we have 2, 5, 1. So this is our row vector. Now we have a column vector. Say BV is equal to 3, 1, and 4. So if we do AV times BV, what we will get is a scalar quantity because this is a result of the dot product of these two vectors. Okay. So and let's say we do it in the other way around. Now BV times AV. In this case, we will get a 3 by 3 matrix because this is a 1 by 3. This is a 3 by 1 and this is a 1 by 3. So we will get a 3 by 3 matrix. Whereas for this part here, this is a 1 by 3 multiply with 3 by 1, we will get 1 by 1 matrix, 1 by 1 array, which is indeed a scalar. Now another example is, let's say we have a matrix A that is equal to this. So this is our 3 by 4 matrix A, and say we define B, a variable B that is equal to 3. So if we do B times A, we will see that all elements in A will be multiplied with 3 because 3 is a scalar. Okay, we can do the same. Let's say also we can do A times B, which will also result in the same answer. Okay, or we can also do, let's say C is now equals to A times 5. And of course, every element in matrix A will be multiplied with 5. Now we're going to take a look at array division. In the previous lesson, we have discussed on how to create identity matrix with the command EYE. The identity matrix is a square matrix which the diagonal elements are 1s and the rest of elements are 0s. When the identity matrix is multiplied with another matrix, that matrix is unchanged. So for example, we have a matrix, a 2 by 3 matrix of 7, 3 and 8, 4, 11 and 5. When we multiply it with an identity matrix, we get the same matrix. The next is the inverse function. The matrix B is the inverse of matrix A. If the two matrices are multiplied, the product is the identity matrix. So if we multiply matrix A with its inverse, we will get an identity matrix. So the function to create an inverse matrix is INV function. Let's take a look at an example. Let's say we have a matrix A. So this is a 3 by 3 matrix. So to create an inverse of matrix A, let's say we name this B. So B is equal to INV of A. And when we press enter, we will get the inverse matrix of matrix A. So when we multiply A and B, we will definitely get an identity matrix. We can also multiply A with A to the power of -1, which will also create an inverse matrix of matrix A, and we will also get an identity matrix. So it's either you create the inverse of A by using the function, or you multiply it with A to the power of -1. Now let's take a look at array division. So the first one is left division, where the division begins from top left going down. So it is used to solve the matrix equation of AX equals to B. In this equation, X and B are column vectors, and this equation can be solved by multiplying the inverse of matrix A on both sides. So we have A inverse of A multiply with AX equals to inverse A multiply with B. So in the end, we will get X that is equal to inverse of A multiply with B. So in MATLAB, this equation AX equals to inverse of A times B can be written as X equal to A left division B. This is useful to solve a simultaneous equation. For example, we have here three equations with 3 unknowns. So we can rewrite this in matrix form, taking all the coefficients to become 4, -2, 6, 2, 8, 2, 6, 10, 3. And then there is another column vector of the unknowns x, y, z. and this is equal to another column vector 8, 4, and 0. So to solve this equation, we can use the left division. So example here, we define the matrix A, that is our coefficient of the unknowns, and then we define the column vector for the right hand side of the equation. Say we name it B, so it has to be a column vector for left division matrix. So to solve the equation for the unknowns, we simply use the left division function. So x is equal to a left division b. We will get the value of x, y, z. So minus 1.88 is for x, the second value is for y, and the third element of the column vector is for z. We can also, instead of using left division, we can multiply it with the inverse of A. For example, xb now is equal to inverse of A times matrix B. Then we will also get the same answer as what we do with the left division. So this is equal to the equation that we have derived earlier. Another division in array is right division. This is just the same thing, just that now x and d are row vectors instead of column vectors that we have for the left division. It solves the same equation like what we had previously. So now the unknowns x, y, z is written as a row vector, and the coefficient of the unknowns remains as a matrix, and then the right hand side of the equation is also written as a row vector as well. So the only difference between left and right division is how you write the vector form of the unknowns and the right hand side. So let's take a look at how we implement this in MATLAB. Let's say we have the matrix C of the coefficient of the unknown, and now we create a row vector D as the right hand side of the equation. So to solve for the unknowns x, c, we can use the right division where it begins from the top right. So we will get the same answer, but now as a row vector. We can also use the inverse multiplication. So D is multiplied with the inverse of C. We will also get the same answer. Now let's take a look at the element by element operation. Previously, multiplication and division that we have discussed follow the rules of linear algebra. However, in many situations, it requires the element by element operation. So element by element operation in MATLAB can be done only with arrays of the same size, and this is by including the dot symbol. So let's say you want to do element by element multiplication. Instead of typing just star, you type in dot star. Same goes for exponentiation and also division. So let's say, for example, you have two vectors A and B. So if you do element by element multiplication, A dot star B, you will get A1, B1, A2, B2, A3, B3, and A4, B4. And the same goes for division and also exponentiation. For an array, for example, if we have a 3 by 3 matrix A and a 3 by 3 matrix B, when we do element by element operations of A dot star B, for example, instead of following the rules of linear algebra, now MATLAB do A11 times B11, A12 times B12, and so on and so forth. And this is also the same for division and also exponentiation. So let's take a look at how this is implemented in MATLAB. Say we have a matrix A. This is a 2 by 3 matrix A, and we also have another 2 by 2 matrix B. Okay, so if we do element by element multiplication, for example, A dot star B, then we will also get a 2 by 3 matrix as the answer. So definitely 2 is multiplied with 1, 6 multiplied with 4, and so on and so forth. If we, let's say, do not include the dot symbol, we will definitely get an error because the inner dimension of matrix A and B does not agree. So this cannot be, the multiplication cannot be performed according to linear algebra rules. Now let's say we have a matrix C, which is the division, element by element division of A dot divide B. Then we will also get the same method, element by element operation. That is 2 divided by 1, 6 divided by 4, and so on. And we can also do the exponentiation, for example, B dot power 3. So every single element in matrix B will be to the power of 3. But if we exclude the dot symbol, we will MATLAB will give us an error. So element by element operations calculation are very useful. For example, to calculate a value of a function of many values. For example, we have an equation y equals to x squared minus 4x. So let's say we define the vector x to have a certain range, for example, from 1 until 8. Now we want to know what is the value of y for every value of x. So in this case, the element by element operation needs to be used. So the command that we should type in is y equals to x dot power of 2 minus 4 times x. And for 4 times x, there is no need to include the dot symbol because 4 is a scalar. So multiplication of an array with a scalar doesn't require element by element operation, but the one that requires the element by element operation is the exponentiation of 2. So when we press enter, we will get the value of y for every value of x. Now let's take a look at another example. Say we have this equation here. So we're going to define the range of z. Let's say z is equals to 1 until 11 with an increment of 2. So we want to know what is the value of y for every value of z. So we need to type in the equation of y here. So y is equal to z dot power of 2 dot power of 3 z dot power of 3 plus 5 times z. There is no need to include the dot for multiplication with 5 because obviously 5 is a scalar. And for division, we also need element by element division. So dot divide. Now 4 times z, again we don't need an element by element operation here. And now to the power of 2, we need to use the element by element operation again. So z to the power of 3, z dot power of 3 plus 5 times z dot divide 4 times z dot power of 2 minus 10. So that should be the equation for y. And when we press enter, we will get the value of y for every value of z. Now let's take a look at a few built-in functions that we can use with array. Let's say, for example, we have a vector A that has 4 elements. So we can calculate the mean of all elements in the vector A by typing the command min A. When we press enter, MATLAB will return the mean of all elements in the vector A. Now suppose we have vector A with more elements. We add more elements to vector A, and if we want to find the maximum, if we want to find the largest element in the vector A, we can use the command max. Say now we assign this to a variable C, so C equals to max A. MATLAB will return the largest element in the vector A, that is equal to 11. Another command is we can type in d comma n within a square bracket equals to max A. MATLAB will return two variables. The first one is the largest element, d is equal to 11, the largest element, and n is equal to the position of the largest element, which is the fifth element. So if we use this command d comma n equal to max A, we will get two values, the largest element and also its position. We can also find the smallest element by typing the command min. So if we type in min A, we will get the value of 2, which is the smallest element in the vector A. And we can also use the same command d comma n equals to min A, which will produce two values. The first one is the smallest element, and the second one, n is equal to 3, is the position of the smallest element in the vector A. Now we can also calculate the sum of all elements within a vector by typing in the command sum A. We will get the summation of all elements uh, in the matrix or in the array. We can also use command sort. The command sort will sort the value in the vector A in the ascending order. We can also calculate median by typing in median A. MATLAB will give us the median value of all elements in the vector. We can also calculate the standard deviation by typing stda. MATLAB will return the standard deviation of the elements within the vector A. Now another built-in function is that, for example, let's say we have a matrix A. This is a 2 by 2 matrix, for example. Okay, and we can calculate the determinant of matrix A. Determinant is the calculation multiplication of the diagonal element minus the other multiplication of diagonal elements. So 2 times 5 minus 3 times 4 should give us minus 2, and by typing in the command det A, we will get the answer of minus 2 as well. The other built-in functions is to calculate dot product and dot product and cross product of vector. For example, we have two vectors, vector A and vector B. So we can calculate the dot product of these two vectors by typing in dot A comma B, and we'll get the answer of 26. Dot product will produce a scalar value. And we can also calculate the cross product of A and B by typing in cross A comma B, and we will get the another vector as the result of the cross product of A and B. Now let's go to the generation of random numbers. There are a few commands that we can use to generate random numbers. The first one is rand. If we type in rand, MATLAB will produce a random number between 0 and 1. So the random number produced is larger than 0, but it is smaller than 1. We can type in A equals to rand in bracket, for example, 1 comma 4. This will produce a 1 by 4 array of random numbers. Each element has a value of between 0 and 1. If we type in the command again, we will get a different value, of course. And we can also type in rand in bracket 3. This will produce a 3 by 3 matrix of random numbers between 0 and 1. And we can also type in rand 2, 4, which will produce a 2 by 4 matrix of random numbers between 0 and 1. So that is the rand command. We can also produce another type of random numbers with is using the command randi. This will produce an integer between 1 and the maximum number. So if we say randi in a bracket 15, 15 means the maximum number, the highest number. So the random number produced will be between 1 until 15. So MATLAB has chosen 12 as the random numbers. If we execute the command again, we will get a different values that is between 1 and 15. We can also produce an array using randi command. So randi, for example, the command should be typed in as 15, the I max. I max means this is the maximum number of the random integer, comma, rows, comma, columns. So if we give randi of 15, 3 only, MATLAB will produce a 3 by 3 matrix, a square matrix that contains random numbers between 1 and 15. We can also type in randi, I max is 15, 2, 4, which will produce a 2 by 4 matrix of random numbers between 1 and 15.